Hey guys, it is Miss Smolik here. We're trying something a little different this time because this lesson is pretty much a review when we're talking about fractions, decimals, and percents. And so what I'm going to do is I'm going to walk you through the Google Slides that I would normally do in front of the entire class, and then you're going to complete some problems on your own based off of what you learned in this video. So our I can statements for today are: I can explain the difference between terminating and repeating decimals. I can write fractions and mixed numbers as decimals, and I can write decimals and fractions as mixed numbers. So talking about decimals, because you can divide any integer by any non-zero integer, which just means a number that's not zero, you can use long division to write fractions and mixed numbers as decimals. These decimals are rational numbers and will either terminate or repeat. So we can see the difference between a terminating decimal, which is a decimal that ends. So 1.5 doesn't have any other numbers after that 5, so it terminates or ends. Repeating decimals have a pattern that repeats. So negative 1.333 ... means that the 3 goes on forever and ever. And to show that a decimal repeats, I can put a line above it. These are terminating and repeating decimals. To convert a fraction or mixed number to a decimal, you have two options. You can either use long division or find an equivalent fraction. For example, negative 2 1/4. If I wanted to write this as a decimal, I know that my whole number in the decimal would be negative 2, and then all I do is focus on the fraction of 1/4. I can either find a relationship between the bottom number and 10 or 100, since that's the place value that our decimals are in, or I could just do 1 divided by 4. I know that 4 goes into 100 25 times. So if I multiply 4 times 25 to get to 100, I would have to multiply 1 times 25 to get 25, which means I would have a new mixed number of negative 2 and 25 over 100, which means my decimal would be negative 2 and 25 hundredths. For the second example, negative 3 11ths, 11 is not a factor of 10 or 100, so I have to use the long division rule. When I divide, I would do 3 on the inside of my division symbol, the dividend. 11 would be on the outside, or the divisor, 3 divided by 11. When I do that, I find that it comes out to be 0.272727 forever and ever and ever. So that is a repeating decimal, and I can put a line over to the 2 and the 7 to show that it repeats. Here are a few examples that you can try on your own. At this point, if you would like to pause the video and give them a try, I would recommend doing so. We can write terminating decimals as fractions, kind of going the opposite way. 3 simple sayings to keep in mind to go from a decimal to a fraction or a mixed number. Say it using correct place value, write it, and then reduce it if it can be simplified. For the first example, negative 0.26. To correctly say this, I would say negative 0 and 26 hundredths. And since I'm saying hundredths, I know that the number 26 has to go over 100. And so my fraction would be negative 26 over 100. And then I would simply reduce it, but by dividing both the 26 and the 100 by 2 to get a final answer of negative 13 over 50. For the second example, negative 3.1, I would say as negative 3 1/10. So to write that, I would write negative 3 with a fraction of 1 over 10. I can't reduce it, so that's my final answer. Again, here are some examples that you can try turning decimals to fractions. So if you'd like to pause the video and give them a try, please do so. This is a modeling real life question. I'm not going to go over it. If you would like to give it a try, you can. But at this point, what I would like you to do is to try the practice problems that I have handed out to you in class. Good luck.